All right, can we apply the product rule? The answer is yeah, sure we can, why not? So the product rule says take the derivative of the first function. So that would be 5x to the 4th power, and then multiply by that the original second function. And then leave the first function alone and multiply by the derivative of the second function, which we know to be 1 over twice the square root of x. And this particular homework question said, don't bother simplifying it, but I'm going to simplify it. And so I'm going to do that by finding a common denominator. So what I'm going to do is rewrite this as the 5x to the 4th times the square root of x. I want a denominator of 2 square root of x. And so I have to put a 2 square root of x in the top too. And the other one already had that, so that's just going to be x to the 5th over twice the square root of x. Now that there's a common denominator, I can pull together the numerators. Now, cool thing about this new numerator is that the square root of x times the square root of x is x. So when I pull that together, I'm going to get a 5 times 2, is 10. And then x to the 4th times x is x to the 5th, plus that x to the 5th over there. Oh, this cleans up nice. All divided by twice the square root of x, which gives me 11 x to the 5th over twice the square root of x. That was totally worth it. Holy moly, look at that. Did I do that right? Let's double check some things here just to make sure that's not just wishful thinking. I found a common denominator. So this is the denominator here. So I just introduced it to that function by dividing and multiplying by twice the square root of x. And then the square root of x times the square root of x is x. X times x to the 4th is x to the 5th. That looks good. And then 5 times 2 is 10. Yeah. Oh, that looks good. That's the derivative function right there. Wow, that was totally worth cleaning up. And actually, I could take it farther. So let's do a little kind of cheating, kind of not. The power rule that we talked about before, my proof only proved it for whole numbers, but it turns out we've seen evidence, like with this function right here, that it actually applies to, it seems to apply to functions that have a fractional power or a negative power. And I can rewrite this right there, because x to the 5th square root of x is x to the 1/2. If we multiply things by the same base, then we get to add the powers. 5 plus a half is 5 1/2. 5 halves is 11 halves. So that would be x to the 11 halves. And if I take the derivative of x to the 11 halves with the belief that the power rule does apply here, which we again have some evidence that it does, let's see what happens. Power rule says bring the power down, 11 halves, and then reduce that power by 1. So if I take 11 halves and I subtract 1, 1 is 2 halves. 11 halves minus 2 halves is 9 halves. So that gives me 11 halves x to the 9 halves. Now that doesn't quite look like what I have above, or does it? Check this out. Here's my 11 halves. Okay, well, that's cool. That matches. What about x to the 5th over the square root of x? Well, remember, the square root of x is really x to the power 1/2. And if you divide two numbers with the same base, you subtract the numbers. What is 5 minus a half? Well, 5 is 10 halves minus 1/2 is x to the 9 halves. And so holy moly, the power rule works on this particular rational power. Wow, math is amazing sometimes, all the connections.